I don't want no oil spoiling my shoreline. I like fish much better than crud. I like birds and things creeping and crawling. Won't trade no more oil for blood. The sun done give us all we need to make this country run. But that black demon oil's got us fussing and fighting, and I do believe it's time we was done. I don't want them nukes run by them kooks who think radioactivity is fun. No more three-headed frogs or kids with leukemia. Nuclear power ain't fit for a dog. The sun done give us all we need to make this country run. But that nuclear power's got us fussing and fighting, and I do believe it's time we was done. No nukes! Good morning, Toledo, and good afternoon, Columbus, and hello to those of you listening on the internet, wherever and whenever you are. My name is Joe DeMare, and you are lucky enough to have tuned into For a Green Future. For a Green Future is a show where we talk about ecology and the environment, and we talk about them in the ways that they affect you, your wealth, your health, your happiness, and your family's happiness, your pets' health, and the health and wealth of literally everything around you. And that's kind of a theme of today's show, everything around you, because we have a special guest who we did an interview with. His name is Dr. David Smith, and he is from NASA, and he is an expert in aeroplankton, or as the scientific community calls them, bioaerosols. Anyway, he's going to be talking to us about the things that live in the air and that travel on the winds and get up into the upper atmosphere, and some of them even make their way out into outer space, actually. But that's a very fascinating topic, and one not people don't talk about very much, so we were very lucky to be able to get an interview with David Smith, and we're grateful to NASA for making it possible. This show is a recorded episode, so you won't be able to call in at 866-240-1065. So I know probably there were dozens of you with your fingers on your phones, right, ready to call in, but you're going to have to save it for next week. I'm sorry. But still, it's a good show, and looking forward to doing it. We will, as usual, after we talk to David Smith, we will be hearing from our sponsors, and then we'll be talking about some environmental news and information. We'll have our letter from the future, and it's just going to be a great show, that's all. So this week was kind of interesting for me. I managed for the first time to get out to Camp Miakanda, which, if you're from Northwest Ohio, if you're from the Toledo area, you've heard of Camp Miakanda, most likely. It's a Boy Scout camp. It's been going since something like 1917, and in fact, it holds the oldest Boy Scout building in North America that was built way back around 1917, and this is a camp which has been there forever, and thousands and thousands of Toledoans growing up went to Camp Miakanda. And I just wanted to talk a little bit about the importance of places like that, because it's only 160 acres, but it is very heavily wooded. It's got a nice lake. It's got streams running through it. It's right next to the Ottawa River, and so it's an important spot for wildlife. I heard hawks, and I saw many different kinds of geese there. When I went down to the lake, there was something in the water. It didn't quite break the surface, but there was something huge in there. Maybe it was a catfish, maybe it was a muskrat, I don't know. But There's lots of trees and critters and plants and birds, and there's no substitute really for getting exposed to that kind of wildness. I mean, even if it's only 160 acres, you can still get that sense, that feeling of being in nature and being in the wild. And you really could tell when you've been in the wild, because after you're done, you feel better, you feel relaxed, you feel more confident, uh, because we are meant to have nature experiences. Things like trees and forests are sort of locked in our DNA, and there's something clicks into place when you get out into the woods. And it was the first time I've been to Camp Miakanda. I didn't grow up in the Toledo area. I grew up in Western New York, actually, where there's quite a few really cool Boy Scout camps. But the experience of being in nature in that way, there's literally no substitute for it. And I know that in this time of COVID, things like scout troops and groups aren't meeting. So I'm thinking, if you've got kids, then I make an effort to get them out into the woods, to get them out camping. Even if you go as a family, you can still get that wilderness experience. And Camp Miakanda, being so old and historic, has all kinds of historical markers, those plaques that explain things all over it. And I read a few of them, and one of them pointed out that a whole slew of scientists and nature reporters and people who became important in the scientific community had their first sort of taste of things like biology, and at Camp Miakanda, where they would go and they would see, they used to have animals that you could pet. They'd had a reptile so that you could pet, and animals that they kept, and that kind of exposure to nature is what leads a lot of people then down the path to learn more about nature. And once you learn more about nature, it can be addictive. I have to say that. I have to admit to that addiction, that once you start learning about ecology and the environment, once you start getting a picture of the whole incredible system that fits together all over this globe to keep us alive and to keep our air breathable and our water drinkable, once you start to fit all those pieces together, it does become an addiction. You do want to learn more and more, and it's like, oh, what's this thing? Mycoplasms? What are they? Oh, how do they fit in? Aeroplankton? What the? And you start, and you start doing that knowing that you're never going to fully comprehend the whole thing, because there's just too many pieces. There's millions of species of insects, and each of them does something unique in their ecosystem. There's millions upon millions of kinds of bacteria, and really the way we try to classify bacteria doesn't really do bacteria justice, because we try to lump them into nice, neat little categories. But in the real world, bacteria are a lot more messy than we give them credit for, because they're always swapping DNA with each other and turning into other sorts of bacteria. And it's really just an incredibly complex web. And you're never going to figure the whole thing out, but as you learn more and more of it, you just get a deeper appreciation for it, and you kind of get into awe that this incredibly complex system has been keeping us all alive for all the tens of thousands of years that human beings have been on the planet. And you also gain a deeper appreciation for just how terrible it is that we are actively in the process of destroying it. And there's no denying that. I mean, I'll be talking a little bit about this in the news and eco news section, but some of the things that we're seeing happen, some of the changes that we're measuring, if you have an idea of ecology, literally have the potential to make the planet uninhabitable for us. there'll still be microbes around. Like I say, the bacteria are really tough, but humans, we are sawing that branch off that we're standing on. But one of the main things I want to focus on in For a Green Future, one of the main reasons I created For a Green Future, is that once we recognize this, and once we stop sawing that branch, and once we stop putting these things in the air that are causing so much trouble and wreaking havoc in ecosystems all over the planet, the earth will heal itself. The water and air will eventually clean themselves. And Camp Miakanda, which right now is a sort of a unique little oasis in the Toledo metropolitan area, it's this really cool deep forest right in the middle of a city. That will become the norm rather than the exception, because one of the points that David Attenborough made in his A Life on This Planet, which if you haven't seen it yet, it's on Netflix, I recommend it, is that key to solving global warming is rewilding. Taking all these millions upon millions of acres that we have turned into lawn, that are just sitting as unused parking lot, that's one of the things that burns me up the most. Is, a building could be completely abandoned, but it might have 100-acre parking lot on it, which serves literally no purpose except to prevent water from getting down to renewing the water table. We need to turn all those spaces back into the sort of wilderness that's supposed to be there. We need to let nature rewild, because wilderness, I've said before on this show that wilderness is the infrastructure of freedom, which is true, but wilderness is actually the infrastructure of survival, because it's the wilderness that supports us. Now we think, it's the farms, our farms support us. And, it's the fishermen support us. But without the wild aspect, eventually the soil will become depleted, and eventually the farms will become unproductive. And without wild areas where they could respawn, the fish stocks will be depleted, and we won't be able to fish farm, because fish farming depends on wild stocks for the food to feed the fish in the farms. So basically we have to rewild, and places like Camp Miakanda, where they have these beautiful buildings, these rustic buildings mixed in with the trees, they're just right there in the forest. There's one section of lawn, it's called the parade ground, right in the middle, and that's where they have their assemblies and do activities that require grass. But the rest of the 160 acres are forest mixed in with buildings, and it's just a reminder that we can live like that. That's a very nice, a very pleasant way to live, and we just have to give up this idea that everything has to be shaved, everything has to be nature has to be dominated. We can't allow it to grow and create the trees that it wants to create. We've got to keep everything stopped. And once we realize that, we can make it happen. And why is it important that we do that here in Ohio? What does this have to do with the world? Well, again, the theme for today's show is everything is connected. And my guest is going to talk about that, because literally the bacteria that are in the air travel all around the globe. And I've said before that the individual atoms of your body, that, when you breathe in and out carbon dioxide, or breathe in oxygen, breathe out carbon dioxide, there's so many atoms in a breath of air, and they get mixed so thoroughly up into the atmosphere that you are literally, some of your carbon atoms were inside the bodies of people like Gandhi and Jesus, and things that are being breathed in and out by lions on the Serengeti, some of that is being breathed in and out by us. It's literally the same air. And what the study of aeroplankton or bioaerosols shows us is that some of the bacteria that are put into the air in places like Africa or Europe actually get all the way over here, and they affect things right here in North America, right here in Ohio. So everything is connected. So if you let a tree grow, we talk about how if you put carbon into the air, that can affect things all over the planet. But by the same token, if you take carbon out of the air, if you let nature restore itself, if you let nature rewild, the benefit of that benefits the entire planet. Also, that tree that you let stand in your yard is helping to combat global warming over the entire globe. So, just a kind of an upbeat version of the everything is connected. So it's time for our interview with Dr. David Smith, and hope you enjoyed it. All right, well, let's start with your name and your position.
My name's David J. Smith. I'm a NASA research scientist at Ames Research Center in California. However, I'm currently on a programmatic detail assignment to NASA headquarters as program officer in the Science Mission Directorate in the Planetary Science Division.
Ah, that's cool. Well, could you give our listeners a basic idea of what aeroplankton is?
Sure. Microscopic life floating and drifting through the air. There's basically an ocean of atmosphere above our heads that we're somewhat oblivious to in our daily lives. It's easy to forget. In a sense, we humans are bottom dwellers underneath this ocean of air. So aeroplankton are these overhead microorganisms. And it's an informal but relatable description since most folks are familiar with marine or freshwater plankton in bodies of water. The more conventional terminology in the scientific community is to refer to airborne microbes as bioaerosols, and that's a broad, inclusive way of categorizing basically any type of biological entity in the atmosphere, cells or pieces of cells or debris suspended in the atmosphere. And, just for frame of reference, we refer to any particle in the atmosphere as an aerosol. And I think most folks are used to seeing aerosols in the atmosphere with their own eyes, right? Like dust in arid regions of the country or smog in cities, or nowadays across the U.S., lots of smoke from wildfires. So in the same way that dust and smoke spread in the atmosphere, so do microbes, usually riding winds and natural convection that flows between the Earth's surface and its atmosphere. So my research team studies those dynamics, and I'm happy to tell you more about some of our discoveries today.
Oh, great.
In the discipline that we refer to as aerobiology.
Okay, so bioaerosols. Okay, I'll remember that. So would you say that we're just beginning to understand how important bioaerosols are for life on Earth? For example, it wasn't that long ago, was it, that we discovered that the bacteria Pseudomonas is important for cloud formation and rain?
You're right. We are just beginning to understand the influence of bioaerosols on what's occurring both above our head and on the surface. In fact, Joe, estimates place the total amount of bioaerosols in the atmosphere at anywhere from 5 to even 50% of the total aerosol mass in the atmosphere. That's larger than about 2.5 microns. So to frame that maybe in a more familiar way, like if you were to take a milliliter of cloud water, on average there'd be about 10,000 fungal cells and 100,000 bacterial cells, which is just stunning. And it really wasn't recognized by the scientific community until relatively recently. And now suddenly some of the atmospheric chemists and meteorologists are kind of having to reconsider how some of their models work and some of the underlying assumptions, particularly with respect to what triggers precipitation. Microbes can influence cloud formation and precipitation. This is collectively known as bioprecipitation. And one particular bacterial genus you mentioned, Pseudomonas, has been well studied for its influence on cloud formation and precipitation. So, for that to occur, water needs to nucleate around a particle. And these so-called cloud or ice condensation nuclei can be something that's, inert, a non-biological particle, or it can be a living or dormant particle, a bioaerosol, or even a fragment of something that was alive on the surface. And so it's really fascinating, this field of bioprecipitation. To say a little bit more about Pseudomonas and one species in particular, Pseudomonas syringae.
Well,
it's been found to have some proteins Yeah, go ahead.
I just want to put a, like you said, nucleate around. I guess in layman's terms, that would be sort of glom onto, might be a way to phrase that.
Right.
Okay, so they
Yeah,
glom onto
exactly.
these things.
Without going into the detailed physics, Pseudomonas syringae has these proteins on the outer coat of its membrane that improve ice nucleation, and so when the organism gets lofted into the atmosphere, um, it can basically make that a process more efficient to form cloud and ice condensation nuclei and ultimately precipitation.
Uh huh.
So
Cool.
yeah, it's a very interesting relationship between microorganisms that make their living on the ground, get swept up into the atmosphere, and can influence the weather. I can say a little bit more beyond the influences on precipitation.
Oh
Kind
yeah.
of what we're starting to
Yeah, please do.
uncover about, yeah, sure, some of the impacts of microbes in the atmosphere go beyond just precipitation influences. There are epidemiologists that are interested in potential disease dispersal corridors in the atmosphere. Now, this is just barely underway, and there's a lot more work that needs to be done to start to tease out any potential relationships between airborne microorganisms and the outbreak of, say, agricultural pathogens. But it is an important aspect of getting a better handle on what's floating above our head and where it's going, and what happens when some of the biomass lands in downwind regions. Can it influence the health of those ecosystems? And so that's an important aspect of the field of aerobiology as well too.
Uh huh. Okay, so how do you measure something like bacteria floating high up in the atmosphere? Yeah, what techniques do you use?
There's a few different collection methods, and it depends on where you're located and the altitude of interest for sampling. I have been involved in studies ranging anywhere from just going up on to the roof of a building and using a high volume pump to capture air, or going to the summit of a mountaintop where you can access air masses that are relatively pristine and uninfluenced by nearby cities or surfaces. But more recently, the NASA research team that I lead has modified a sampling contraption that flies aboard a high-flying NASA aircraft that can go up to about 40,000 feet. And the way that works is we basically stick a sterile tube out the window, and that can bring in large volumes of air that passes through filters that we can then take back to our microbiology lab for analysis. And the system has a control such that we can turn the airflow on and off and be precise about when and where we're making the collections. And importantly, the system can be cleaned regularly to reduce any influence of contaminants. So we have published a couple of those initial studies from the high-flying NASA aircraft, and I guess I'll let your curious listeners go read up on some of our results. But suffice it to say, the system is working pretty efficiently now, and we can make collections using this NASA aircraft on missions that last for about 6 hours.
Huh. Okay, that's cool. What first got you interested in this field of study? Because there's not many people who study this, as far as I can tell.
Yeah, Joe, you're right. I don't know. I was reflecting on sort of where I've been and how I got started in this field recently, and I don't know, maybe it was my parents were always playing Bob Dylan records in my house growing up. The answer's blowing in the wind, as Dylan said. I am, as a biologist, just like super interested in the interconnectivity on our planet, and wherever the winds blow and the connections across continents between distant ecosystems through the wind, to me, is just so elegant and interesting and understudied, and it makes the world seem a lot smaller when you start to recognize the influences of distant continents on one another. And so I think that is at the root of my interest in aerobiology, whether it's dust that drifts over from the Sahara Desert and reaches the United States after crossing the Atlantic Ocean, or microbes that do the same jump across oceans. Long-range transport is happening, and we have so much left to learn. But I think that is the essence of my interest in this field.
Huh. So, literally, we're all interconnected by these living things that are floating around. all of us on all the different continents. Are there any organisms that you found that live entirely in the air, or are all of them just sort of temporary visitors floating on their way to somewhere else?
Right. Based on what we know today, they're all temporary and just drifting in whatever direction the winds are blowing, which is to say that eventually the airborne microbes or the bioaerosols will fall out due to, gravity or precipitation like we discussed earlier. But that can take a while, depending on how high up the airborne microbes get dispersed.
Interesting. And, since you're from NASA, what do you think of the recent news about Venus having chemicals associated with life in its clouds? Do you think it's possible there could be an atmosphere-based life on Venus?
We'll just have to watch the scientific method play out, Joe. You know how it goes. Teams will propose an idea or observation and see if it holds up over time. And, that is how we make strides and progress. And definitely look forward to reading some of the follow-on studies. I can say it has definitely put a lens on aerobiology, terrestrial aerobiology, some of the exciting questions that you and I were discussing, which I think is wonderful. And with regard to Venus, there doesn't seem to be a lot of water in the Venus atmosphere. So if extant life is there, it would have to figure out a way of managing severe dryness, not to mention corrosive sulfuric acid conditions and other stressors. And I guess I'll just say, whatever's responsible for that uncertainty in the Venus atmosphere will require some additional observations and missions. So let's hope we get to go explore our nearest planetary neighbor again sometime soon, since it's been a while since we sent a spacecraft there.
Now, what are some of the long-term benefits we might see from studying bioaerosols?
Well, I'm really glad you asked this question, because I'm a big believer that basic exploration and microbiology can benefit society and yield some unexpected valuable surprises, really. Maybe we can talk a little bit about what is referred to as bioprospecting. Perhaps we'll discover some hardy microbial survivor from the upper atmosphere that has some sort of ultraviolet radiation resistance mechanism, a biochemical sunscreen, if you will. And something that we haven't, figured out yet or haven't discovered is just overhead, just from, making sample collections in extreme environments. And, while that may seem like a long shot, the field of microbiology and astrobiology already has examples of some of these transformative discoveries born from just basic exploration and surveys of environments we think are extreme. Like, for instance, you may be familiar with Taq polymerase, this heat-stable enzyme, which is used in every biology lab today, especially for diagnostic tests for diseases, for example. And this enzyme was found from a bacterium Thermus aquaticus, which was living in these boiling hot springs of Yellowstone, where nobody at the time could have imagined microbes surviving, until a group from the University of Wisconsin just scooped up some water, took it back to the lab, and figured out what was living in there, and then later isolated these thermostable enzymes that we're so dependent on today. So, again, I think that underscores the importance of basic exploration and all the unknown surprises. Now, let's go back to Pseudomonas, that genus we were talking about earlier, the one that we know from Pseudomonas syringae anyway, can influence precipitation. There already have been spin-offs from the isolation and study of that organism. Some ski resorts today are using those proteins derived from that organism to produce snow more efficiently with less water and energy. So, that's an example in aerobiology of benefits already to society, at least if you ski and snowboard.
Well, I do ski, mostly cross country, but I do love a good snowfall. So that's cool that they've already taken some things we've learned about bioaerosols and applied them that way. All right. Is there anything else that you'd like to add that we haven't covered about on this area?
Yeah, sure. I think we're all stuck indoors nowadays, and I would just encourage anybody that wants to do some science at home to be an aerobiologist. If you're interested in this topic, you don't even need a microscope or a DNA sequencer. If you've ever tried making bread, you can be an aerobiologist, right? Try cultivating some sourdough starters near an open window in your house throughout the year. see how it changes as the seasons change, or different times of day, or different weather conditions outside. And I can tell you this, the outdoor bioaerosols are variable, and that diversity will be reflected, for better or worse, in the deliciousness of your homemade bread experiments. So, that could be a fun thing for some of your listeners to do, or with their kids that are interested in science. And I am fascinated by the field of aerobiology, and I really hope that people are too. And it's been really fun talking to you about it today, Joe.
Yeah, I've really enjoyed it. So thanks so much, Dr. Smith, for coming on. All right. Well, we are very grateful to Dr. Smith and NASA for that interview. We're also very grateful to our sponsors. These are the people that keep paying us to keep on the air, and they're responsible for this show. We're very grateful to them. For Green Futures, brought to you by the Wood County Park District. The Wood County Park District is a natural resources conservation agency. They protect natural spaces, maintain quality green spaces, provide engaging programming, and they teach people to love and respect nature. They restore wildlife habitats, and they lead outdoor adventures. Wood County Parks protects natural spaces in Wood County for all to enjoy from 8 a.m. to 30 minutes past sunset every day of the year. There's several ways you can get a hold of them to see what's going on. One is to call them at 419-353-1897. That's 419-353-1897. You can also check out their website, wcparks.org, and they have a nifty app at the App Store. Just search for WC Parks. And, of course, they're also on Facebook. So the Wood County Park District. For Green Futures, also brought to you by our patrons. And these are people who've gone to patreon.com. They searched for a Green Future, and our page popped up, and they decided to make a small monthly donation. You get to decide how much you want to donate, and every month, a tiny little bit comes out of your checking account and comes over to our accounts, and this is part of what keeps our show going. So we're very grateful to our patrons on patreon.com. That's patreon.com. We also have some announcements, and if you have a organization and you're doing anything related to the environment or ecology and you'd like it announced here on the show, you would just send an email to joe@joedemare4agreenfuture.org. That's JOE at Joe DeMare, DeMare is DEMARE, foragreenfuture.org, and we will very probably read it on the air. And this week we wanted to remind you about the Wood County Park District's Masked Hero Geochase. It's a self-guided geocaching adventure in the parks, and it started way back October 5th, and there's two more. Today, the 25th, is the last day you can go to the Cedar Creeks Preserve at 4575 Walbridge Road and follow some instructions and do some geochasing via geocaching and catch a villain that's trying to destroy nature. So this is, as I say, today, the 25th, is the last day you can do this at Cedar Creeks. But then from the 26th through the 31st, you can also do it at Sawyer Quarry Nature Preserve on Lime City Road in Perrysburg. So those are our sponsors and our announcements. Now it's on to eco news and information. And as I said at the start, gave a little bit of foreshadowing there. There is something that's happening right now, a bit of science news that is very, very worrisome. It is really not looking good. And that is that the Siberian ice has not yet formed. And you are probably asking, well, who cares about Siberia? And what we're talking about specifically is the sea ice off the coast of Siberia. And the reason this is important is because that ice that forms off the coast of Siberia every fall, that ice is essentially sort of the seed ice for the North Pole. So if no ice forms in Siberia, because what happens normally is the ice gets formed in Siberia and then it gets carried by currents up over the North Pole and over to the other side of the globe, where it breaks off around Greenland and Iceland as icebergs and melts. Well, if it doesn't get started in Siberia, if ice doesn't form off the coast, that could mean no ice in the Arctic in the summertime. No, in other words, no ice cap at the North Pole. And so the scientists are extremely worried. There's a story on October 22nd in The Guardian, and the title is "Alarm as Arctic Sea Ice Not Yet Freezing." And so this has been the date where the sea ice forms has been getting later and later. And right now, this is the latest it's ever been. So we've broken yet another record. And sounding kind of like a broken record, those of you who remember phonographs, this is another sign that we're caught in a positive feedback loop. This is a situation where the effect of the global warming is to cause more global warming, because the whiteness of that ice at the North Pole is one of the most important factors for reflecting sunlight back out into outer space so that it doesn't heat the globe. And so if you eliminate the ice, then the Earth will absorb the heat at that spot in the North Pole, and then that will accelerate global warming even further. Not to mention the fact that as the sea ice makes its way across the top of the planet, essentially it sort of gathers up nutrients in the ice as it floats along, as it's carried by the current. And so then when it gets to the other side around Greenland and Iceland and breaks off and melts, it releases all the nutrients that it's gathered, and that is part of what allows the phytoplankton in those northern seas to have the nutrients they need to grow and bloom. And as we've talked about this before, so if the phytoplankton don't get what they need, if the phytoplankton don't grow, then the little things that eat the phytoplankton, the zooplankton, don't grow, and then the fish that eat the zooplankton don't grow, and the little fish that eat the big fish don't grow, and ultimately it ends up with we don't get any fish. No fish for you, because without the nutrients that these glaciers, that these icebergs carry as they cross the polar ice cap, without those nutrients, the entire marine food ecosystem can collapse. And this is just yet another sign. And the scientists that are quoted in this article are kind of despairing. They're kind of like, we're telling you people over and over again that the carbon in the atmosphere is doing all these terrible things, and yet the governments aren't moving. And if we don't move, if we don't react, if we don't get off the carbon habit, if we don't stop doing that, these terrible things we predict and the scientists predict will happen. And so it's not rocket science. It's just basic chemistry. Different things hold heat at different rates. Carbon holds heat much better than the rest of the atmosphere, carbon dioxide. And so if you increase the amount of carbon dioxide, you increase the amount of heat that the atmosphere holds, and that's causing all these terrible problems. And so this leads directly into the next bit of eco news that I wanted to talk about, and that is this coming November 3rd, as we all know, is the election, the big election, presidential election, lots of elections. But there's, in terms of the history of the Earth, a more important date is the next day, November 4th, because November 4th is the day that Trump or whoever's president that could actually withdraw us from the Paris Climate Accord. Now, the Paris Climate Accord is insufficient. It calls for reductions in carbon dioxide, which is great. It doesn't specify how countries can get there, which some say is a necessary flexibility, but it still only cuts carbon by about half what you need to for us to actually survive. Still, it is a step. It's that first baby step, and it's insufficient, but it's something. And what we've discovered in country after country is once you take that first step, once you start moving towards a carbon-free economy, it kind of gains steam. You kind of get a steamroller effect because you start realizing, oh, we don't need carbon for that, and oh, we don't need carbon for that. We can do this without carbon and that without carbon. And before you know it, you can make radical changes. You can radically change your economy without losing your quality of life. And in fact, in most cases, improving your quality of life by dumping carbon. And in other words, once you start trying, you find out you can do it. Trump doesn't want us to start trying. That's why he has said he's going to pull us out of the Paris Accords. And November 4th, the day after the U.S. election, is the day that he can finally fully do that. And so it's just something to keep in mind that politicians come and go, parties come and go, but the planet stays, and the things we do to the planet have lasting effect. And so if we pull out of the Paris Accord, that is bad news for the rest of the world. Most of the rest of the world has stayed in the Paris Accords, and most of the countries of the world are trying to meet them. They're having differing levels of success. And as we know from our interview last week with Diane DeRigo, if they try to do it through nuclear power, they find out that they don't actually reduce their carbon significantly. But if they actually try to switch over to wind and solar power, then they find that not only can they do it, but there's all kinds of unforeseen benefits of doing it. That think that the air is cleaner, wealth gets distributed. In other words, local regions get more economic benefit out of it than they did from fossil fuels. All kinds of wonderful things happen once you start, and most of the rest of the world has started. But we, thanks to our current administration, we are headed in the wrong direction, in the opposite direction. We are working towards increasing our carbon output. Now, COVID has worldwide caused reduction in carbon output. That's why there's an oil glut right now, and that's why gas prices are so cheap. But COVID isn't enough to keep those carbon numbers gone or to keep them low. But what we're discovering is the countries that are attempting to come out of the COVID downturn through clean energy sources like wind and solar, those countries are actually rebounding quicker, and their economies are healthier than ours and other countries that try to just go back to the way things were as a completely dependent on fossil fuels. And that is a terrible thing. And the dependence on fossil fuels, just as switching over to clean energy has all kinds of unforeseen benefits, remaining on fossil fuels has all kinds of tangential problems with it. And the last story I wanted to talk about today is one of those problems, and that is there's an oil tanker off the coast of Venezuela that is threatening the entire Caribbean. The name of the tanker is the Nabarima, and it's a Venezuelan oil tanker. It's also owned partly by an energy company from Italy called ENI. And what happened in 2019, Venezuela had elections, and the U.S. didn't like the results of the election. The U.S. said, we don't like the guy you elected. What you need to do is get rid of that guy and put in the guy that we pick. And the Venezuelans refused to do this, and so the U.S. has imposed all kinds of sanctions on Venezuela, one of which said that this tanker full of oil, which had Venezuela and the Italian company had a deal about selling that oil, it was blocked from selling the oil. And so what ended up happening is the crew abandoned the ship. It's just been sitting there since 2019. It's moored, it's anchored, but there's nobody on it. And it is carrying 1.3 million barrels of oil, and that actually comes out to 54.6 million gallons of oil. And that oil is threatening to get into the Caribbean, and if it does, the entire Caribbean Sea, literally every coastline, is going to be affected because the currents that swirl around in that area will carry it to every beach in the Caribbean. And this is an unacceptable situation, and unfortunately, the ship is taking on water. It's in fact it's heavily listing to one side. It's getting very close to an actual to sinking, and if it does sink, it will destroy coral reefs in the region. It will destroy fishing. There's 50,000 fishermen in Trinidad and Tobago alone that rely on the sea. And it is just a situation that is unacceptable. And so, but this is part of what happens when you stay dependent on fossil fuels. When you stay dependent on oil, there's going to be oil spills. There's going to be ecological disasters. That's one of the side effects of oil. And so, much like what happened off the coast of coast of Africa earlier this year, there's a whole bunch of organizations and a whole bunch of hand wringing and a whole bunch of nothing actually being done to remove the oil from this tanker or to save the tanker, prevent it from sinking. It's just an example of what happens when your policies, your environmental and your political policies, don't have any basis in reality. Things end up getting destroyed. So it's listing at what's estimated, according to an article in Forbes on October 21st, it's listing at about 25 degrees right now, which, if you're a boater, you don't want your boat listing at 25 degrees. It's just not very good. And they're especially concerned because hurricane season is not yet over. And even though we've had an incredible record hurricane season goes until the end of November, November 30th. And it's quite likely that another hurricane is going to come right through here and could finally put the finishing touches on sinking the ship and releasing the oil. So that's a bad situation, and I really, it's important that we do something about it, but so far at this point, nothing is happening. It's just sitting there continuing to sink, and so we have to watch that. All right, now it's time for one of my favorite sections, and that is our letter from the future. And every week there's a flash of photons next to my bed, and this letter from the future from my great-great-granddaughter Marie I appears from the year 2300. Here's this week's letter. Dear great-great-grandpa, things are finally starting to settle down here on the Kola Peninsula. We are finally starting to get some good science from the army of researchers that have joined us here. Even Louis Bambino is behaving himself. I think he was taking some heat from the other scientists for his boneheaded play for more lab space to study the stuff. Oh, we can't call it the stuff anymore. That was pretty unscientific. Now it's called Sync Life. That's SINC for the silicon, iron, nickel, and carbon that it's composed of. We came up with that name at a meeting with all the scientists. We also all agreed that it is alive. It shows all the signs of life. It will even move towards food, that is, the elements that make it up, slowly at about the same pace as a plant root. It seems to use heat as an energy source, the same way plants use light. It can withstand incredible amounts of pressure, and we've discovered that even though it looks like a pile of noodles when it's separated from its rock matrix, those noodles do have a front end and a back end. The front end is tipped with an incredibly sharp diamond that tapers down to a point that is a single carbon atom. This is how it drills through semi-plastic rock deep in the earth. How it generates or maintains that diamond, we have no idea, but we're learning more every day. It's an exciting time to be a scientist. Love you, GGG. Marie I. So it's kind of reassuring to know that even in the year 2300, they don't still have everything figured out. So we're coming up to the end of the show pretty soon here, and I just wanted to say thank you very much for listening. This is the highlight of my week when I get to talk to all you folks. And in fact, the highlight of the week came on Thursday for me this week because, as I've said, this was a pre-recorded show. And much as we enjoy getting your calls at 866-240-1065, we weren't able to do that this week. As you know, Mick Gonzalez of the Cheap Seats is coming up very shortly, so you'll be back to sports in just a minute. But I also wanted to make a pitch for getting some feedback from you folks because we've been doing this show for over a year. In fact, this was our 94th episode, and it's always good to get feedback. And so there's several ways to do it. One is you can send us an email at joe@joedemar4agreenfuture.org. Another way is you can go to either our podcast or our YouTube video, and you can leave comments right there on the podcast or the YouTube video. The podcast is from Podomatic, so you would go to podomatic.com and search for a Green Future, and there all our past episodes are listed, all the wonderful interviews with people like Lois Gibbs and for the deputy ambassador from Germany, and of course soon the one that we just did with David Smith will be up there. You can leave a comment on any of those episodes, and if you just want to leave a general comment, you can just leave it on the most recent episode, and I get notifications when there's been comments left. And you could also go to our Facebook page. We have a Facebook page which is growing in terms of the number of likes. We're getting new likes every week now, which is great. And we just wanted to, we'd like some feedback from you. Do you like it? What do you like? What do you don't like? I've said this before, but I went to teacher school. I have a master's in education, and one of the things my professors used to say is, there can be no learning without feedback. And that's very true. If you don't get any kind of feedback, you have no idea how you're doing or what you're doing. And we love getting feedback of any sort, positive, negative, whatever you like. Just let us know what you think about the show so far. And of course, consider becoming a patron. Consider going to patreon.com and signing up to get a little bit taken out of your checking account every month and making a donation to For a Green Future. So that's it. That's our show for this week. And just remember that theme of everything being connected. When you go out and look up at the sky, think about the fact that sky, that air above you is filled with bacteria, with pollen, with fungi, fungal spores, with living things. You're not just looking at air and water when you see clouds in the sky. In that is a literal soup of life, and we are constantly moving through that soup and sort of swimming in it, and it literally connects us. It connects all the life on the planet. I remember when I was young, one of the fascinating little stories I read was studies of volcanic islands, and how a brand new island would appear in the ocean, and it would very quickly start to become populated. They studied it, and first some spiders showed up, and then some other insects showed up, and then some plants showed up, and at the time they didn't realize, because they we're still looking at all on the macro level. But on the micro level, these bacteria and fungi and spores, they would start showing up immediately because they would drift down from the atmosphere and sort of seed that new land with life. And that would make it possible for the other plants and animals that came along later. So we are all connected, and like I say, that means both that we can hurt everything by what we can do, but it also means that we can help everything by what we do. Every time you actually do something to help the environment, every time you actually take a positive action, it affects everything. As I've gotten older, I've become more and more convinced of that truth, that everything you do has a consequence, everything you do matters. So do the right thing, help the environment, stop making choices that hurt the environment, and if we all work together, we will get to the green future. So thanks again for listening. This is Joe DeMare signing off.
I don't want no oil, a spoiling my shoreline. I like fish much better than crud. I like birds and things a-creeping and crawling. Won't trade no more oil for blood. The sun done give us all we need to make this country run. But that black demon oil's got us fussing and fighting, and I do believe it's time we was done. I don't want them nukes run by them kooks who think radioactivity is fun. No more three-headed frogs or kids with leukemia. Nuclear power ain't fit for a dog. The sun done give us all we need to make this country run. But that nuclear power's got us fussing and fighting, and I do believe it's time we was done.